hear me? Should we start? Where's the people? I know that's gonna go around the show. Let's gather in the lecture room. You starting this? So, why, why is it always like that when you are in this kind of situation? All right. I see some people. I see some people. What did you do with the mic? I feel that people are still. Is it good?
People coming.
Come on. No? We all good? Ready to start? Ready to roll? Almost on time? I don't know. Has Anthony help us? How far should I be from the mic? How is this? What? Closer? All right, I got this. Yeah. They, I think we fixed it. It's very loud. How about now? I switched to the other one. So thank you so much for joining tonight. It's amazing to see so many friends coming by in this amazing space for the grand opening of Constructing Futures. So welcome, everyone. We are. Thanks for reminding me about the run of show. My name is Sara Kodarin. I'm an assistant professor of architecture, Lawrence Technological University College of Architecture and Design, and I'm the co-curator of the show, designer and co-curator of the show, alongside Carl Dubman, the dean of the college. And so this has been an exciting adventure. We saw a little bit of, hey, I just keep saying hi to many friends that I'm seeing today. We have an amazing run of show today. Please, during the grand opening, bear with us. We have to do a round of thank yous for all our supporters and partners and sponsors. But we'll follow hopefully an inspiring panel discussion about the future of construction. So we started working on this in February. Actually, my dear friend Michael Harrison reached out to me saying, hey, at Bedrock here we have some ideas. You know, we think that we should raise conversation around technology and the future of construction and how those things link together. And we figured that you and Carl are interested in technology. You
like robots.
I like robots. That was the starting point of the conversation. And so, do you have some ideas? What should we do? And so that's how the conversation started. And basically, they accepted all our ideas. We said, how about we do an installation related to a call for AI images? We'll talk about that in a second. They said, yes, that sounds great. So that helped spread the word out. And we said, how about we bring some robots into the space and we do some demos and we have fun with that. I like robots, so anytime I can, I talk about robots. And they said, yeah, why not? That sounds great. And how about we also bring into the space a large-scale concrete 3D printer and we try and do some demos and see how that works? And they said, yeah. And this is how all of this happened. And you want to add anything to that? OK, sounds good. I think that's your turn to talk, though, Carl.
Maybe I'll drop this. So we're going to start with some... How far away did you hold this?
I don't know, try something.
So the space that you're standing in, all of these things wouldn't be possible with a number of different supporters and sponsors and others, some of whom are here tonight. We had a lot of support from Lawrence Tech, both within the college as well as the president's office. Unfortunately, the president couldn't be here tonight, but he sends his regrets. But we've also been working with Bedrock since February on a number of things. And so we'd like to introduce Kevin Mall, who's the Senior Director of Urban Strategy and Innovation for Bedrock. And I think this has been an amazing collaboration over the last 3, 4, 5, 6 months or so. And here we are.
Yeah. Whoa. All right. Sorry about that, everyone. Good evening. Yes, my name is Kevin Mall, and I work in Bedrock's Office of Urban Strategy and Innovation. And it's my pleasure to welcome you to our wonderful space here, 1001 Woodward. My role at Bedrock specifically focuses on innovation platforms where we create space for people to come and test and innovate new technologies. 2 existing platforms that we have that I spend a lot of time on. One of them is called the Detroit Smart Parking Lab, where we innovate on parking technologies, and then the other one, which you see the logo there, the Urban Tech Exchange, which is right up the street, where we focus on smart building technologies. Those are great representations of how Bedrock is committed to creating environments and spaces for new tech to be deployed and for innovation to happen. And this collaboration with Lawrence Tech here at 1001 Woodward with this Constructing Futures deployment that you see is a great representation of where we can bring together real estate, development, construction, and new technology into a space and invite the community in and the ecosystem in to come in and engage with us and push those ideas forward. So we have a great panel arranged for you tonight, but before we get into that, a couple of thank yous that I'd like to offer. In return, thank you to the Lawrence Tech team, Sarah, Carl, for your amazing work bringing this space to life. It's never looked better. Also to Design Corps for their support and for creating this opportunity. I believe this is the 14th straight year for Detroit's Month of Design, so thank you for that. And then a special thank you to all of my colleagues at Bedrock who are relentlessly focused on innovation and for their great work shepherding this process and this deployment. And special thanks to Matt Churchwell and Ryan Mason for all their individual contributions to make this happen. And of course, thanks to all of you for being here tonight. Hope you have a wonderful evening. And I'd like to now introduce Bonnie Fahum to come up and say a few words from Design Corps. Thanks, Bonnie.
I'm going to use my prompt, if that's okay with you guys. Thank you for having me. Thank you to Lawrence Tech and to Bedrock for producing this event for Detroit Month of Design and inviting Design Corps to be here tonight and be part of the event. It's an honor. And thanks to all of you for being here and helping kick off the first week of the 14th annual Detroit Month of Design. With 95 events featuring 250 designers in 80 unique locations, the festival lineup this year promises a vibrant series of talks, workshops, tours, open studios, and exhibitions, this being one of many. While it's going to be a blast for all of us, let's remember that the purpose of the festival is more than a party. Month of Design serves as a platform for connecting designers to each other and to new opportunities, connecting emerging talent to industry, and highlighting the value of design for community and business. By showcasing the creativity and innovation coming from our beloved city, we can show the world why Detroit was named by the United Nations Educational, Scientific, and Cultural Organization as the first and only UNESCO City of Design in the United States. Design Corps' mission is to continue establishing Detroit as a globally recognized and valued creative capital, and to position our city's creative legacy as a competitive advantage for attracting, retaining, and growing talent, businesses, jobs, and residents in our great city. We know that Detroit is an industrial powerhouse with a prolific past, but we want to prove we have an even more relevant future. What better way to uplift designers and leaders than the Constructing Our Futures exhibition? On behalf of myself and my co-executive director, Kiana Wenzel, and the entire team at Design Corps, we thank you for being part of Month of Design and welcome you to experience any of the other 90-some events that are still to come this month. Have a great evening tonight, and thank you again for inviting me to be here.
So we are extremely thankful to our sponsors and supporters and partners for helping us make this happen. And in particular, I want to start thanking, and then we'll go through the list, but I want to start thanking the Consulate of Italy in Detroit, because you guys have been amazing supporters. They are making culture in the city. You're great, you're connecting people, and I would like to call on stage for an address the Consul of Italy, Allegra Baistrocchi, please. Please help me welcome her.
Grazie, buonasera. This was not expected, so thank you, Sara. Thank you, Carl. We are strong supporters of LTU, as you know, and specifically of COAD. I think Sara does incredible work with robots. We're also fans of robots at the consulate, so we did a fantastic event on AI with her last March. Thank you, Carl, for all that you do as Dean, because you have a great vision, as well as your president. They have great vision, and LTU is really an excellence that we have here in Michigan. I've been here 3 years. Thank you, Mr. Mall, for saying the space has never looked better. We've been in it the past 2 design months, so just saying. But as you all know, Italy is a strong advocate for anything design, and more recently of anything AI. So under my Prime Minister Giorgia Meloni's presidency of the G7 this year, we put AI very much at the forefront of world leaders and what needs to be done for it. We were the first country in the world to actually give itself an AI regulation. We are the 3rd country in the world for use of AI in the workforce, because over 24% of workers actually use AI daily, which is shocking. I mean, I use it as well, so not so shocking. And so it's opportunities like this to show people exactly what is the potential of AI, how can it be used in the future for good. And obviously, I wanted to thank for the opportunity to speak. We will be back here with Sara on Tuesday, so if all of you are at all available at 6 p.m. We have the world champion kickboxer, Gloria Peritore, who is obviously Italian. She is the world 55-kilo kickboxing champion, but more importantly, she is a strong advocate for the end of domestic abuse, and she tells her story about how she used since she was a victim, let's say, of domestic abuse, she used sport as a way to overcome and actually redesign her life. So it is somewhat design-oriented, and we'll be here at 6 on Tuesday, in case you guys want to come, and grazie.
Yeah, and so just to mention some of the other sponsors, and as Sarah mentioned, all the things that she wanted to happen in the space that are all happening tonight. So after the panel discussion, we've got some robotic demonstrations over on that side with our ABB robots. ABB is a sponsor. We have a number of firms where we have many alumni and leadership positions there. So Albert Kahn, Rossetti, and HED, we're all sponsors. As part of some of the work that we're doing, Sarah and I started a new company, and so there's the 3D printer that's here is through Plop. And then I also want to thank the Castell, all the chairs that are here weren't here yesterday. They are here today. And so amazing support and being able to have the furniture for the month. And then Nor Technologies is also here. They're over in the back corner there. And one of the things that I would point to, we used, there's a very nice, cute little yellow robot that will be roaming around in the back. And if you look around the bottom of the walls, there are blue lines. And so one of the first things that we did is we used that technology to print our floor plan, our digital floor plan in the space, and then built off of that. So very thankful to all of our partners that are here. And then also this couldn't be possible, probably, I forget when we started, maybe 3 weeks ago, building and doing the construction in the space. The difficulty has been, you can imagine how vast and large this space is. How do you feel like you occupy a space like this? And so part of the design was to imagine how we create space, how we define different rooms, different activities, and all of those things that happen. And so since we've started, I know Kevin introduced Ryan and Matthew. We've had almost probably weekly, bi-weekly, tri-weekly, quad-weekly meetings happening throughout this time as we continued to craft what we were going to be doing, how we were going to be programming the space. And then a lot of support from staff within the College of Architecture and Design. Jen signed you in as you entered. Other staff that weren't able to be here tonight. But then there were also, well, I'm looking at Jeff Evergreen and Aaron helped us to CNC cut all of the construction that you see here, as well as a number of students, some of whom are here tonight. So I don't know why they're stuck between the walls, but Sarah and Sophia are in the back corner. Dane is over there, and so the three of them, Manny is also here. Manny is there. So, and then who else is missing? Matthew and Reese. Do I see Reese? No. So these students have been incredibly helpful working throughout the process. So I don't know, are you guys looking for jobs? Do you need jobs? Yes. Okay, so I would recommend them very, very highly. They're hard workers, so if there's any industry people in the room, what? Yes, keep going. Next slide. What's that?
Just vantage point.
We like that.
Yeah, just in one sentence, we use Rome a lot as a site for inspiration, a site for design. So kind of like we wanted to share with you an aerial photo of the show so that you have a point of view that kind of shows how the space works. And we used a lot Baroque architecture in Rome. We're calling this the Detroit San Carlino, and we played a lot with poches, again, to think about the space and how to make space out of this amazing and big gallery. And so that's the, we wanted to, we think it's always inspiring to see how creatives and designers are approaching generative AI. And this is the second year that we propose a call for images. International call has been successful. And last year, so we wanted to propose that again on the topic of the future of construction. And so what we're seeing on the walls are the selected prints from our submissions. So we received more than 1,000 submissions from 25 countries. So we're very happy that we can really share with you diverse perspective on just ideas and inspiration on the theme of the future of construction and technology.
And like maybe we shouldn't belabor these things, but I think there's also, we talk about generative AI and the ability to think about crafting things in the future and being part of a discussion. And so opening this topic up to a broad audience to think about how they may see these things changing. And so really the exhibition and the conversations and the programming that we're having this month is a way to imagine being part of a broader discussion. And what better place to do that than within Detroit, where there's an incredible history of manufacturing and technology. We have this space for the month and we're going to use it. And so we're holding our lecture series down here. We've got other, we're holding a mass timber symposium on September 19th and 20th, as well as other lectures and meetings and alumni groups, and the president is holding a panel discussion. So watch the website and through Design Core, through scheduling for that, and there'll be lots of things happening in this space throughout the month.
You ready for the panel discussion?
Let's do a panel discussion. So,
Always gets excited.
we need this for the online, right? Otherwise, I would just talk loud. So we wanted to host a panel discussion tonight as well. And so what we're going to do is we've got 3 panelists joining us, and they're going to share 10 or 15 minutes on their different perspectives, and then we're going to open it up for questions and then make some connections between some of the things that we're talking about. So we want to do this. How about we do one? So
I don't know, but maybe I'll.
So Nilufar Imami is going to be our first presenter, and so maybe I'll just do separate introductions, and then we'll go from there. So Nilu's a researcher, educator, and designer looking for gaps, intersections, and overlaps between architecture and multiple disciplines, using computational tools and fabrication techniques to provide creative yet performative solutions. She holds a PhD in architecture with a major in building technology from the University of Michigan, post-professional Masters of Science in Architecture, also from the University of Michigan, and a Masters of Architecture from the Iran University of Science and Technology, and a Bachelor of Architecture. I've been following her work for a while as she established the Digital Technologies in Architecture, DITA, research lab at Illinois School of Architecture in Urbana-Champaign. And so she's going to share some of her work tonight and help us open up this discussion. Okay? Use this carefully.
Okay. Good evening, everyone. It's a pleasure to be here. Carl, Sarah, thank you so much for the kind invitation and for organizing this amazing exhibition. So we were given a prompt on how do we see the future of construction is going, that short. And I have decided to show some of the projects and the thought process of myself and the things that has been going on in Detail Lab and my studio teaching at University of Illinois with you. Thank you for the introduction, so I'm not gonna reintroduce myself. The only thing that I'm going to add to the introduction is that I have practiced as an architect back in Iran, and when I came to the US, I have done an internship at Autodesk Incorporation, and I have also taught at multiple institutions, Kendall College of Art and Design at Ferris State University, Louisiana State University, and back to Midwest University of Illinois at Urbana-Champaign. Glad to be back to Midwest. So I want to start with this slide. And according to EPA, 600 million tons of construction and demolition debris were generated in the United States in 2018, which is more than twice the amount of the generated municipal solid waste. As architects, we should not only think about design, but we should think about the way that it's fabricated, constructed, and then the waste and the afterlife of what we are designing. So currently, construction is mainly an after-the-fact consideration. Once design is completed, we think about, okay, how do we want to construct it, or give it to a construction company to construct it for us. But that is certainly about to change with additive manufacturing techniques. Design, fabrication, materiality, and construction are going to all be integrated and need to be considered simultaneously. And that is what I think the future of construction is, integrating design, fabrication, and construction. But how do I attempt to integrate these, and how do I go about it? I want to backtrack from construction. So Gilles Retsin says that the question of automation in construction or automation in architecture is, in the first place, a question of design rather than a question of robots. automating the existing analog syntax of buildings does not make much sense. A building consists of, on average, 7,000 different parts, and any attempt to automate these many different processes is ineffective. However, if the syntax of building can be reduced to just a few elements, automating their assembly and construction becomes more feasible. So given this framework, in my projects, I focus on design and fabrication of parts that can be aggregated into wholes. In particular, I focus on repeatability in design and reusability in fabrication. Now, coming to focusing on fabrication, I work with materials and processes that allow reusability, such as the 3D printed flexible formwork that you see here, and I use it to cast concrete to create multiple elements. After a couple of rounds of usage, if the mold is ripped off or has lost its accuracy, the plastic has a potential to be recycled and then create a circular economy for fabrication. And then coming back to design, let me see if I can play this video for you. Does it play? Mm-hmm. If it doesn't, no.
Yeah, usually you should have a play button there. I don't see it.
Okay, don't worry about it. So at the design level, instead of designing a whole and then dividing it into multiple parts, I start with designing the parts itself and embedding the intelligence of assembly into multiple variations at the part level. And that is going hand in hand with designing how it's going to be fabricated. For example, in this example, this is a 3D printed resin flexible mold that was designed. So we took a case study and we said, okay, let's reimagine this facade and how we can standardize these modules and create a form but still get some variability out of it. Another thing that I consider during design is saving materials. And for that, I use structural engineering techniques and approaches. For example, I have used topology optimization to come up with the form of these precast panels, and they have complex undercuts, so I have used additive manufacturing to design the mold and cast them. So going over this overall framework, I want to dig deep in 2 research projects, and then I will show you a couple of student projects which shows the extension of my research into my teaching. So the first project that I want to show you today really started with my curiosity on stereotomy. Stereotomy is the art of cutting solid materials, and in particular cutting stones, and then putting them together to create walls. And in particular, there's something named topological interlocking assemblies, TIA, which is a mortar-less assembly, and through the curvatures of each module, they can be assembled without any use of mortar. And I thought that, okay, I want to explore this more. So I created a parametric model of this geometry and then created an arch out of it. I did some structural analysis to see how the arch performs as a whole, and then some discrete analysis to see what module might slide first if we increase the force on it. And I then focused on its fabrication. So I said, okay, what are the different types that exist in this arch, and how different molds should be designed for each type. Then those were 3D printed out of the flexible material and then cast multiple times. So this is quite complex geometry. It has 2 curvatures on both ends. Those are osteomorphic blocks. That's a double curved surface. And then the whole module has 2 big curves on top and bottom of it. So that's quite complex. And I'm taking advantage of additive manufacturing to 3D print a mold for capturing that complex geometry. And this is just showing how many times each mold type was cast to create this assembly. And this research gained some traction. It won an award. It was published in TAD Journal, which is a recognized journal in our field. And once this project was completed, it led me to think about the idea of precast and reusability in design in vertical surfaces on facades instead of like curved surfaces that are like walls. And I started to look at some historical projects where they use precast concrete modules, some as load-bearing, some as non-load-bearing in building facades, especially from 1960s. These were designed and fabricated in collaboration with sculptors to show the capacities of concrete and how malleable they can be. So I studied these, and they can really have a variety of complex geometries, and the earliest ones in 1960s, they are load-bearing, but as we move towards more contemporary ones, they are non-load-bearing and supported by secondary structure. So I started to survey about 15, 16 of current case studies. And I looked at the geometry of the panel, the way that it's connected to a supporting panel, and I came with some sort of analogy. So usually the panel, the thing that I realized by doing this kind of analysis was that many of the precedents have a linear design sequence. First, the module or the precast panel is designed, and then they design the connection points so that it's hidden behind the panel. And I thought, what if we flip this? What if we say these are the connection points and let the form emerge based on those connection points? So for that, I used topology optimization. And the connection points act like as support points, and then the force flows between them and says, okay, here's the best way to distribute material. And this is where we would need more material, let's remove it from other places. And you can do it at multiple target densities. Say, I want to keep 50% of my panel volume, 30% or less. So these are some two-dimensional patterns of panels that have been form-found based on those connection points or boundary conditions in topology optimization. And the same can be done in 3 dimensions. So this time you would need some lateral load that represents wind load, and then some gravity, and then these forms start to emerge. And I actually found these 5 and then picked 2 of them to move forward with fabrication. With fabrication, I was working with TPU, a flexible material, and this image shows how much abuse you can put on the mold and release it. And the reason I used it was because I wanted to cast the undercuts of my form-found 3D topology optimized panels. And these are some of the cast instances. As you can see, oops. So this is an example of an undercut. So there's no way that you can cast this in a regular stiff mold because you can't really take it out. But the flexibility of the material allows you to peel off the 2 sides of the mold and gets more complex shapes. So these are the final installations at a 1:4 scale. And here you can see both pictures from the front and the back. So for example, here you see that there are some undercuts on the back, but then there is some complexity in the front. And this project was also published in TAD, and it gained traction. And finally, I want to show you a couple of more projects coming out of my studio to show you how students are interpreting these approaches. This was a project that the students completed in my fall 2022 studio, and they designed these interlocking modules that could be cast with a mold. And the requirement for them was to create or design a mold that can be reused, or at least 90% or 80% of the mold can be reused. And in this case, all of the outer walls and the base can be reused, and the center needs to be destroyed. But this project won 2 awards, one Spectacular Innovation Award in Chicago, and then it was recognized by Sarah National Design Award. The other project that students completed in my fall 2023 project, again, they designed this module that has curvatures on edges that allow it to interlock with its neighboring modules without mortar, and on the left, you see how the molds are coming together and they can be detached after it's cast, and this shows an assembly of the cast modules. And the final one is this project. It's a bird migratory wall or bird refuge wall, and Okay, on the left you would see that all the mold parts can be come off and they are not like damaged. And then, yeah, they can be assembled without any mortar. They're interlocked in one direction. They might need mortar or like some mortar in the other direction and create this assembly. So to summarize what I showed you, first I focus on design, fabrication, and assembly of parts. They not only open avenues for automation in construction, but allow reversible construction practices. Second, I focus on repeatability in design and reusability in fabrication. And to me, fabrication-focused projects have tangible material usage and waste implications, which can guide us through constructing a sustainable future. Thank you. How did I do with time?
Thank you.
Okay.
Only we won't have to switch the computer. So we're changing from panelists. There are more chairs in the front, so people in the back, if you would like to come in, you could come in. So we can shift slightly. So thank you, Nilu. And I think we're going to pick up on many of those themes that she introduced. So Rolando Mendoza is going to be our next presenter. He's the design director, associate principal at Bermelo Ajmil. Bermeo. Oh my God, what did I do putting you guys next to one another? So Rolando Mendoza, which I'm also probably not saying right? Okay, is a visionary design and construction leader with over 30 years of diverse and unique industry experience. I think you need to update it because I think I've known you for almost 30 years, and that started before that too. His career began in Miami at Carlos Zapata's design studio, where early experiences with hurricane impacts fueled passion for integrating technology with design. His significant tenures at Walt Disney Imagineering, as creative and delivery executive at Mortensen Construction, as director of virtual design and construction, were marked by leadership in significant projects like Shanghai Disney Resort and Las Vegas Raiders Stadium. These showcased his abilities in managing complex projects that merge creative vision with advanced technology. His academic achievements include a dual degree in architecture and design computation from MIT, underscoring his deep commitment to innovative architecture solutions. Now leading efforts in maritime, themed entertainment, and architecture at Bermeo Ajami. Bermeo Ajami Architects. Rolando continues to push the boundaries of design and construction. So welcome, Rolando.
Thank you, Carl. Hello, everyone, and thank you, Sarah and Carl, for inviting me to this wonderful event. I'm Rolando Mendoza. I've known Carl for 30 plus years. Well, we have to. Went to school together at MIT, so we've got a long history, and it's really exciting for me to come and visit Detroit and the LTU community, because I know that Carl is not half-assing his deanship here, and he's really pushing the envelope, and I think we're seeing that in this exhibit. It's really phenomenal what you guys are doing and inspiring this community towards the future. So my presentation is going to be a little more architecture focused. Architectural ideas typically could start in the back of an envelope. And so throughout history, we've seen, the creative mind working through sketches, through intuition, through the hand. And so what you see here is a good example of that. This is a sketch by Frank Gehry, which I had the great fortune of working with for many, many years, really developing the process and the workflow with a bunch of colleagues and collaborators to transform something like this into architecture. And so the process is really simple. You take a sketch, an idea, you start to build a massing model about the program. you start to build the body, if you will, that then you can start to apply architectural ideas on. And then you iterate. There's a lot of iteration and collaboration in the design process. And so what we see here is a design for the Beekman Tower in New York City, where we studied many, many options for that project. And so, the nature of design is about that. It's about iteration, it's about intuition, it's about that sort of spark of creativity and imagination, and then working through it. And then representing that in a physical model to really then begin to explore the ideas of structure, materiality, and so far everything's been pretty straightforward. This has been pretty much the process that we've been doing for many, many years in architecture. But then the complexity comes in, right? How do we then begin to start taking all of this information into the built form? And so what you see here is a process that we had to invent, very similar to Gaudí when he designed the Sagrada Familia. He didn't have computers or computational visualization tools. He had to envision or invent a way that he would be able to describe the construction of the cathedral, but also be able to control the geometry. And so he invented chains, and he hung the chains and the catenary curves, and using mirrors, he was able then to describe what that building was going to be like. So similar here, we're inventing a digital crafted way of developing the architecture. And so using digitizing ARM to find the points that define all of the complexity in that form, and then taking that information into the computer. Here's an example of a CATIA model where we're actually identifying all of the information that we need to be able to then fabricate and construct the building. So that's been the process for many, many years, and it was one that I had the great fortune of doing and embedding myself in, and have developed an expertise around that. Today, we see a lot of opportunities and innovation, not just in architecture, but also in construction. So I guess the videos don't work, right? No, it's embedded in the slide. Anyways, this was a really cool video about augmented reality in construction. So as I was working as the Director of Virtual Design and Construction at Mortenson, we were exploring how to bring data to the trades. How do we bring that information that you saw in the initial slides to the actual people that are going to have to start building this? And so we started developing technologies and workflows that used visualization, used AI, was able to use a lot of robotics so that we can bring design information directly to the field so that the fabricators and the contractors can actually use that to build the buildings more effectively. Today, after many, many years of delving into the world of technology and experiencing really great projects and having the opportunity to build a theme park in Shanghai and work with Frank Gehry and people like Morphosis, and developing those tools, I've stepped into a new role as the design director at Vermelho Ajamil. Not a very well-known firm. It's known in Florida, but it's carved out its experience in maritime architecture, entertainment, healthcare. We have over 200 plus awards and 40 years experience in these markets. And so it's been a great opportunity for me to bring all of this knowledge now to a whole slew of services that are going to, in our opinion, really define the future of the firm and be able to really think about what that future is going to look like. So storytelling through the built environment. I think that's something that's really important. And as we're thinking about AI, how do we begin to imagine these themed entertainments, these entertainment projects that are really about the experience and not just about the buildings or the forms. Incorporating that into, events like cruise ships and landing on an island and having a day at the beach. Today we can start to really envision, before we even design the project, what that's going to look like. And so here's an example of some of those projects that we're doing. Here's the Nassau waterfront and cruise facility in the Bahamas. And then I'm out of sequence, aren't I? So that's the, okay, these are the islands that we're working on. This is the port terminal in the Bahamas. And this is the port in Miami. And so as you can see, there's a tremendous opportunity to bring a whole different experience to how cruise ships and entertainment start to integrate. And so one of the things that we're doing is we're integrating AI. And what we're actually doing with AI is we've created a portal that we invite our customers and our clients to create their own prompts and their own vision. So the idea is that we send them a link, they participate, there's a survey that they fill out, and they imagine or envision what their project is going to look like. So they'll send us those prompts, we'll develop the imagery, and we'll send it back to them. And it's been a really effective way to democratize design, but also make them part of the process. We're doing a project right now with a community out in California that's thinking about a redevelopment of their waterfront. And one idea that we're exploring is how to give this ability to the people in the community so that they can start sharing their ideas with us. So the world of construction and design is, I think, at a moment of inflection. And you're seeing some examples of that here. But this disruption has been going on now for quite some time. And it runs the gamut from urbanization to sustainability, resiliency, engaging communities, autonomous vehicles. I mean, it goes on and on and on. So the opportunities, it's I think, a field of optimism and ripe for disruption. And I think it's just going to take a lot of courage and moxie and hustle for us to be able to take all of this and really start to do something special with it. How do we begin to reinvent the way that we craft design and architecture, the way that we educate the future designers that are going to take on these roles, and really change the trajectory of something that this industry has been suffering for many, many years. We are still lagging behind other industries in terms of productivity. That's a problem. Construction drives economies. Construction is the bedrock of productivity and economic growth. And so I think it's a challenge that we need to face, and I think that we need to face it with a lot of optimism and embrace these ideas. And so I'll end with this slide here. I don't know how many architects are in the audience, maybe with a show of hands. So I'm going to ask a very nerdy architecture question. One very simple ramp. It's kind of a non-space in a museum in Minneapolis. But the question is, there's a Pritzker Prize winner in one of these sides of the ramp. And so which one do you think is the Pritzker Prize winner? It's a more recent modern building. So maybe somebody can take a stab and just take a wild guess. Come on, you can. The bo- The right side. You think it's the right side? All right. Anybody else? So it's the left side. The left side is the more recent, more contemporary, more digitally driven solution to the Walker Art Museum. The left is actually Edward Larrabee Barnes, who is the original designer of the building. If you don't know about Edward Larrabee Barnes, he's an amazing architect that really looked for simplicity and lucidness in his designs. And what you see here is, I think, evident in terms of a question that I would pose as we have this panel discussion, is what is technology doing for us? Is it really improving quality? Is it improving productivity? Is it giving us better buildings or better experiences? I think that's a question that we all need to address, because AI is here, technology is going to continue, and we're going to have to really address that as a challenge for the future. Thank you.
So our third panelist tonight is Brian Ringley. Brian's the Principal Product Manager at Boston Dynamics. At Boston Dynamics, he leads digital twin product development for robotics software applications. Before coming to Boston Dynamics, he worked as a CNC, an industrial robotic arm programmer and machinist, and practiced architecture as a facade modeler and design automation specialist. Most recently, as a construction automation researcher in the commercial real estate market, he piloted stealth construction robotic solutions and commissioned manufacturing lines for industrialized construction. Yeah? Good? Are we good? We're good? All right, here's Brian.
Thank you. That bio really rolls off the tongue, doesn't it? I tried to take a few buzzwords out of that. And I think we're out of the amplification feedback zone now. We figured that out. Although the Borromini ellipse is probably acting as a series of irregular lenses, creating unpredictable acoustic concentrations, so who knows what will happen. I had Carl as I have to say that, I had you as a professor at Cincinnati, and he was a visiting professor that semester, and he saw the CNC machines in our fabrication lab there, and was like, can we use these? And we're like, oh no, those are for the industrial and transportation design students. We don't do that. And he's like, what if we did? And thus began my insane machine fetish. All right, so there's an image here on the, did anybody see this? I should have started this presentation with this video, but did anybody see the YouTube video that I'm referencing on this slide? In which Atlas, the old Atlas now, throws a tool bag up there, which was, just to show that Atlas has hands now and can manipulate things, and everybody was like, that's not OSHA approved. We know that, no, this is not our idea for a construction robot that throws tools at you. This is not a real construction site. This is just our office. But part of what I want to talk about is how we think about new types of robots to automate construction processes, which is kind of where my head's at. And I don't really believe it's not a real vision, as I said, but I don't really believe in the kind of vision on the left, which shows is that your left too? Yep. Which shows, a humanoid robot essentially replacing one for one, like a task. Like, we're just going to make robot workers to go in and work the same way that humans have always worked, which doesn't really make sense to me. And instead to kind of think about them with the image on the right, which is to think about our relationship with animals, which are, by the way, vastly superior to robots still at this point in time. We're working on it, we're trying. And there's a really great book by Kate Darling that talks about if you kind of reframe the way we think about how we work with robots and what the value of robots are in society based on the way we've worked with animals, both the good and the bad, it kind of ends up being a more interesting framework because it's about creating novelty between that collaboration between human machine and not just replacing humans. So that's kind of the basis for how I think about things. And I also just think about like how do we taxonomize these things. So I've worked a lot with Spot, the four-legged robot here. And this is a mobile robot that is used for industrial sensing, used for construction reality capture. It's essentially a carrier of a sensor to perform autonomous remote sensing on sites. So it's not doing anything necessarily. It's not building something. It's going around and it's taking measurements to assist in a process. And Spot actually has a lot of other sensing modalities that aren't necessarily construction-based. So it has computer vision, so it can read gauges. It turns out turning all of your analog gauges into digital gauges is not cost-effective. So you actually need to use AI to read analog gauges through computer vision. We have thermal imaging that allows us to look for overheating motors in things like pumps and conveyor lines. This one is cool. We have ultrasonic sensors that are able to pinpoint noises that humans can't hear and basically draw those in images so you can find out where you have compressed airline leaks that you wouldn't be able to find otherwise. And then on the construction side of things, we've really focused on reality capture. That includes things like just taking photos or taking 360 photospheres or 360 video or doing photogrammetry and 3D reconstruction as well as laser scanning. All of those things together. But how do those things actually change the way we work? One of the lessons I learned is most people don't do reality capture and they still get buildings built. So why would they automate reality capture with an expensive robot if they didn't need reality capture in the first place, which I think is a fair question. So we have to think about what is the end state of this? What actually begs for more data? Because I can kind of see that happening down the road, but somebody who is investing in this from a construction company might not see that. So this is a this is a weird slide because this is kind of real software from Drone Deploy, but then I like photoshopped it based on my memories of how they presented it at a conference. So it's like not literally the thing. So if you have all this information about your site, you have this historical database, you've gone around and you've imaged it from day to day, like presumably that's useful if you can have a conversation with it, if it can kind of problem point to you and you're not just sifting through photos, because all robots do is create more photos, more point clouds, more files for you to store and sift through. So you have to be able to make sense of them. We actually need the software to evolve in order for the use of the data to be necessary and useful, which in turn then drives the robotics. So something I thought was interesting about this demo that I saw, so this would have been about a year ago, which was you could say, I'm going to run some kind of utility like floor flatness analysis, which is a common thing to run. But I might also just want to click on a thing and have the system know what that thing is, and then I'm not typing these questions, the system is suggesting these questions. You clicked on a waste bin, you probably want to know something about the waste bin, and these are the most obvious things you might want to know. This, to me, is an interesting use of AI. And this stuff exists in practice, so this is Drone Deploy. They bought Struction Site. I don't know if any of you have worked with that, but they brought that in as part of their ground robotics and ground capture platform, so you can kind of go through historically and understand where has change happened, where should I be focusing my attention. And there are companies like Avere and Field AI that are looking at segmentation of point clouds. How do we do this with 3D data sets? It's a lot harder of a problem than to do it with imagery, but it's something that's happening. So until we solve that, which we haven't yet, then I don't think there's a ton of value in autonomous robot scanning, although I encourage you to try it out. And then you have offsite manufacturing, which is the thing I really believe in, which is to adopt manufacturing methods for pre-construction. So when I think about like what types of robots we need in construction and not just trying to replicate how we work today and replicate the trades, I think what could we do already off-site? So I have a factory. I turn construction to a logistics exercise. I store things. I've got autonomous robots that can unpack and pack from the factory. I've got autonomous trucks that can move things from the factory to the warehouse to the site. What's actually left to do? So it kind of clarifies the things we should be thinking about, like what avoids replication of field work that would be unnecessary with industrialized construction. And then it kind of opens up to things like, well, okay, like finishing, you still have to finish a thing after you prefab. Although you could argue, like, do you care when you're in like a prefab hotel room and you look at the ceiling and you can see the lines between the prefab like decking elements? Maybe you don't care. Maybe we don't need to finish things, but still, if you do, then you need a robot for that potentially. But I don't think there's a useful distinction between these two things. And you know, the way I think about thinking of these systems is that there has to be a kind of a new ecosystem that combines the affordances of a new modular material system with a robot at the same time. A few examples of this that I think kind of illustrate the concept. This is a project from the Institute of Computational Design in Stuttgart. This uses you know, equipment that already exists, spider cranes, and one spider crane holds a panel, and then the other one, this is actually, you know, a two-armed robot in theory. And those aren't legs. That would be so cool. Those are just outriggers. So close. And so I think you define a new modular material system. You use a machine that already exists and just needs to be automated. And then you kind of couple that with a new manufacturing technique. Here's another example from Built Robotics. So they've taken an excavator and they've modified it to do pile driving for solar fields. So solar fields, like a lot of them, have solar panels that rotate. Therefore, there are different structural loads throughout the solar farm. Therefore, you have a bunch of different pile sizes. So again, it's like a module. It's just some kind of like I-beam that's extruded. It's got a certain profile. It's got a certain length. Those need to be sorted into the machine in a certain order, but then the machine can go through and it knows where to drive them and how deep to drive them and which one to drive. Here's another one. So this is my favorite 3D printer. It's like just a giant Pez dispenser on the end of a truck. And the genius here was just like, what if we made the CMU block bigger? Because it was made for a human hand, but now we have this giant robot we made, so we should make the block bigger. So these are the things that I think kind of illustrate. And they also kind of, they take like a niche like typology. They're not going to solve every construction problem in the world, but what they're doing I think is effective. Skip. So what do I do now? I'm like really on the like prefab side. And I'm thinking about factories, and I'm thinking about how do we automate factories and make factories themselves more efficient. You're all familiar with, like, you know, it's Detroit. You're familiar with robot arms and stuff, but there's a lot in factories that's still manual. So like, what are the steps towards something like a lights out factory? So the way Orbit works is you have software in the browser. You author and schedule inspection missions for Spot. The scheduler on your network then communicates with the robots that are all sitting on docks waiting to do useful work. The robot goes out and looks at stuff and looks for things that are wrong with that stuff. And if there is something wrong, it tells the control room so that they can issue a work order, which is generally for a person to go do, because that's harder, but could be for a robot to do, or this type of robot, or this type of robot that we also make, or this type of robot that we also make. And this is the new version of Atlas. So I started this thing like, we shouldn't just make humanoids to replace people and then end it with showing you a humanoid, but I think it's actually a way to think about, it's a type of form that's starting as a humanoid. It's really like, you know, by manipulation, bipedal. It's a way to actuate a factory. I'm not saying like the factory is a giant robot that needs to have giant motors. I'm saying that we need to create dexterous mobile robotic agents that can perform the work within that factory to optimize that stuff, to basically make industrialized production even more of a reality and get that transferred over to construction. Thank you.
So we're happy to take some questions. You had one ready.
This question may seem very simple, but I wanted to know, what is the difference between a machine and a robot?
Oh, now we need to do this.
Yeah, I mean, The best thing I ever heard was just that a machine is useful and a robot, we haven't figured out how to make it useful yet. So, you know, like a dishwasher, you could like argue has sensing and actuation and is actually a robot, but it's so useful we just call it a dishwasher and we don't think about it. So I think when we call things robots, that is typically kind of betraying the fact that there's novelty there and we haven't quite made it useful yet, is one answer. The academic answer is the sensing and actuation piece, which is a robot is a type of machine that can sense its external environment, make a decision about that environment, and then act on that environment. Whereas not all machines have sensors, therefore not all machines are robots, but that's less fun.
So recently I've been reading about a controversy with a writing competition using AI. And many folks in the creative fields are against AI because it's taking work that was created by other creatives and mashing it all together and letting someone else use it in another way. Do you see that as a controversy in the construction arena as well with AI, like coming from the work of other architects being used as the conglomeration of information that then gets put back out for different output?
That's a really good question, and I think it's one that, as architects, we're still navigating. What happened, I think, when Midjourney came out, a lot of people were just downloading it and playing with it, and it became so compelling that it took on like wildfire. And the industry really didn't have time to set guardrails and guidelines. And so now everyone's kind of backtracking because there are a lot of implications in terms of copyright, in terms of IP, you know, things that are going to show up in images that have been sampled. And you know, one can imagine that somebody could write an AI that would analyze an AI image and be able to determine, well, that pixel came from one of my creations. So I think it's still a vast world that we haven't figured out, but it's here, and I think it's going to continue, and we're just going to have to work through that collectively. I think that the power of AI in terms of bringing creativity, elevating the ability to bring creativity to another level is too compelling to ignore. But yeah, I think that's just something that we're going to have to deal with as we move forward.
I, of course, can't help to weigh in on this, too. At LTU, we've got a policy that's looking to explore it. And of course, there's ethical ways to understand that. And actually, my colleague here, I think, Matt, you described it as an incredible plagiarism machine at one roundtable discussion, early on in a negative way. But Bonnie, the way that I would answer your question is that architects, he's changed, he's been reformed, but I would say that we always use precedent, and I would love for my students to be able to be looking at previous work, and even tonight we've talked about, you know, Borromini and San Carlino as having some influence here. We've talked about Gaudí, and I love the way that Mark Burry talks about Gaudí and that the curved surfaces always catch the light. And it's been amazing as we've been building this project with the curves, there's always a moment where the light is coming across the surface. And so it's those, you know, I think mining history and thinking about our predecessors and all of those creatives that came before us is a really interesting model. And I think it's forcing us to double down on teaching history and visual literacy as a way to be able to mine some of that even more. And here we go.
You know, I think there was an I think it was Picasso who said, good artists copy and great artists steal. and I think it's just an evolution of the process. We're inspired by others. We have eyes. We look at things. We don't operate in a vacuum. We depend on each other, and AI in a lot of ways is just maybe not the great plagiarizer, but maybe it's the great connector. So, and as designers, you know, when we work with a client, and I always use a silly example, the client's like, oh, you know, I want you to design a house for me, you know, by the beach, and I want it to be like this. And so you take that input, and then you go and you start scouring the internet. You know, you go to Pinterest, you know, and you start grabbing images and putting them on a mural board, and they're called mood boards, and that's what they are. And so I think Midjourney has just put that on steroids and accelerated it. So I think it's just a matter of how you approach it and how you look at it, but it is a creative process, and it will continue to be so.
Thank you for that. You've all shown us wonderful and fantastic things in the worlds of design and robotics and prefabrication. I appreciate seeing all those advances. My question for you all is, what are we doing about adoption and how it's basically flat?
Like adoption of technology in construction? Yeah. Well, it's kind of why I stopped working on it. I mean, like, it's a frustrating, construction is a weird industry. We all know this. I mean, I don't even understand how any building gets built. Like, when you really think about how construction works, like, it's a lot of different stakeholders working together, conflicting incentives, you know, in defiance of God's will, a tower rises at some point. And, you know, I've spent a lot of time trying to integrate technology into architecture and then into construction. I'm mostly kind of on like the industrial manufacturing side of things now. And there isn't a silver bullet except to try to think about the way, I mean, we were having this conversation about like design automation and like I wasn't looking when the hands were raised, but I think there are like design students and it's not all just construction people. And we were talking about like interoperability as this like perennial thing. Like if we could solve design software interoperability, we would be so productive. And you know, I've always kind of tried to point out that the problem with that is that that assumes that there is limited labor. And in architecture, there's unlimited labor because you go in after you graduate and, you know, get your like $35,000 to $40,000 salary job and work 100 hours a week. So that labor is like unlimited. That's not the whole industry. Don't be scared. Don't panic. Go get into robotics like me. But you have to question the business practices. So anyway, back to the question. Like, I think the reason that it's so hard is because you can't just like shove technology into a business model and expect it to work. I think we need more entrepreneurship. We need more rethinking of models. Just like simple stuff too, like design build practices, or starting a 3D printing company. As the person who asked the question, like those are the moves to make to kind of create the change you seek in the industry. You can't just, and I think this is why Silicon Valley, struggles with it as well. They're just like, oh, the reason construction productivity hasn't improved is because the construction people are stupid. They just need the technology people to show them how it's done. And then they also fail spectacularly. And I really think it just comes down to business models. And it's not like that's an easy answer. That's still a really hard thing to solve, but it's a slightly different mindset.
If I can, and we'll take a question from you because I'm looking forward to your question. But just to follow up on that, one of the challenges with integrating technology into a design practice and into the business of design is, architects today are working very hard and they're working long hours, and it's not an easy practice. And so if you start to introduce new tools and they seem additive to already what's possibly a 60-hour work week, it's very difficult to innovate and to think, I have some time now to invent or think about a new way of doing something. And so what we need to do is we need to open up more research and more development and exploration within the business model, so that the people that are leading technology efforts in big firms need to have the agency to explore. Maybe they're not billable, maybe they're just overhead, but that's an investment that firms need to think about. And so I always think about, if the tool isn't synthesizing an activity or helping you solve a problem, and it's just adding more work because now you're going to have to learn something new, then you throw that away. You don't use it. One of the greatest innovations in construction was the cell phone. I don't know if you guys remember Nextel, the rubberized like walkie-talkie phones. When superintendents and contractors started using that thing spread like wildfire. Everybody bought one. I think Sprint made who knows how many billions of dollars selling those phones, because it connected people. So you're the superintendent, you're building something, you have access to that data right there and then, so you can call the architect. Hey, what about this connection here? How's this going to work? BIM, on the other hand, which has been the promise of innovation, hasn't had that same impact. It's too nuanced. It's too, what does it do? I've got to spend a lot of time building a 3D model. Well, what do I do with that model? How do I share it with? So there's a lot of unknowns, and as soon as you got 2 or 3 unknowns for a trade partner who's trying to finish the job because he's got to move on to the next one, you've lost that adoption opportunity. So I think what we're seeing with these new technologies is that they've got to be democratized. They've got to be easy to use, and people have to be able to understand it right away. Oh, if I grab this hammer, I know what to do with it. So we've got to kind of think in those terms, in terms of how we introduce these things into our industry.
I just want to add 2 points to the things that was discussed so far. One of them is from the perspective of academia and how younger generations are absorbing all of these technologies ahead of time, and they are thirsty for it. And the companies try to actually hook our students onto certain platforms. For example, there are free licenses of Autodesk available to students, and once they are once they have invested some time learning it, they kind of get used to using it, and that's how new knowledge is kind of transferred to practice. So I think looking at education probably is a great starting point to help the younger generation to adapt to these new technologies. And then at the other level, let's say a construction company wanting to adapt the technology. The current model is very economic based, and if a new technology costs more and removes the margin of profit, then there might be some resistance for that company. Not all of the companies are willing to be working with a star architect or try something new. At the time that on your slide you had the Disney hall, I mean, he was probably the only person that was working with CATIA and willing to experiment. Everyone else was just like doing the normal. So those few people who first have the money to do that and are willing to do it, they can push it, and then hopefully the rest follow them.
I'll just, yes, economics play a big part of this, but I think the money question for innovation and for innovators has to be put aside. If we want to advance and it's cost driven, then there's always going to be limitations in terms of of making those advances. This city became known as Motor Town for a reason, and there were visionary people that came in and said, you know, we're going to put cars in every road in the world, and they did for many, many years. Then the economics of things started playing into it, and we saw what happened. So.
And I'll answer it a fourth way. Good question, Tom. I would just say we have 3 examples here, and so I'm happy that Nilu talked about education. I think we start thinking about how young people go into the workplace. I think Brian nailed it with thinking about the role of the business model and the way those change, and that was something that was exciting for me about starting the conversations with Bedrock as a really integrated model where there's a discussion about how that works from a kind of finance perspective all the way through to how you deliver something to a client. And I think Rolando and I have a long history of just hacking technology. Last night I talked for hours just about, like, we don't accept that technology tells us what to do. We take technology and we do what we want with it. And so there's a kind of culture drives some of those things and desire drives some of those things. But I think we're still beholden to the kind of logistics and other types of things, and how we balance that or think about those things, I think, is important. But I think we have 3 models here that are thinking about how these technologies might change and different ways of doing that and different scales of doing that. Renee has a question.
Neela, you put on the slide this tons and tons of refuse that comes after construction. So it brought to my mind, what is the future of construction in the reusability of the things that you showed on your slide? It also begs the question to me about sustainability. We're talking about constructing futures. What about sustainability and reusability?
Thank you so much for the question. When I think about reusability, it can be at 2 different levels. First, I'm going back to the precast example so that I can point to the different components of it. First, the mold itself can be reusable during the process, so be it cast multiple times. That's something that's not new. It has been practiced in industry. Then the plastic itself can be shredded, clean shredded, and then filaments can be recreated, and then we use that filament again to 2D print. So reusable, the tools that have made it. The second part is kind of going towards reversible construction techniques, meaning that right now if you want to demolish a building, the parts are not necessarily reusable, they go to landfill. Now, if they are designed in a way that they can come off, so let's say in those mortarless assemblies, they can be disassembled and then maybe assembled into a different shape in a different assembly on a different site. Then that's another level of reusing the components for a different purpose. So when I think about reusability in design, I think about the designed object and how that can be reusable, and then the way that it's fabricated, how that process can also be like repeated multiple times. Does that answer your question? Do you want to add something to that?
Hi, so I think this is less so a question and, well, kind of, doesn't matter. Anyway, my point is, I'm curious to hear about how you guys are thinking about time, because on the one hand, we're thinking about sustainability, reusability, and kind of like the slowness of how we're using material, but on the other hand, you've also mentioned productivity. So more broadly, I'm just kind of interested in hearing about how you think I mean, it might not just be value, but how we value time in a future where some processes are going to become so compressed where they're almost instantaneous. But on the other hand, we're looking at what do those effects look like long term. And I'm curious to hear what you guys might think might change in terms of how we're looking at that.
The other thing that I did in the interest of time is I told them to fly the drone over at 7 no matter what was happening. And so we've got wine, we've got food, we've got the panelists here who I'm sure are willing to talk for more time. And so I'd say there's this. There's the robot printing demo over on the side. We're doing some robo drawings over in the front with Sarah. And so I'd say, let's have some wine and let's continue the conversation in some smaller pockets and other types of things that are happening. Ah, now there's a breeze, which is really nice. So thank you everyone for coming. Great conversation, and let's continue the conversation.